Okay, sorry for the delay. So may now, without further ado, I would like to extend on the invitation to Ms. Malini Samititi, our SEDEC Secretary General, to deliver opening remark. Madam Secretary General, please.
Thank you, Mr. Wu. Good afternoon, everyone. Distinguished speakers, representatives from SEDEC member countries, SEDEC Deputy Secretary General, ladies and gentlemen. Welcome to SEDEC webinar on aquatic genetic resources for food and agriculture. First of all, I would like to express my sincere gratitude to FAO experts, Dr. Graham Mayer, Dr. Daniela Lucente, for sharing the update on aquatic genetic resources for food and agriculture with us. My sincere thanks gratitude also extend to Dr. Maria Rovina from the Philippines for her introduction on Aquatic and its application. This webinar will focus on the importance of aquatic genetic resources and its role in ensuring food security and sustainable development. In addition, it is aimed to raise awareness among SEDEC member countries on aquatic and facilitate the preparation and implementation of the global plan of action for conservation of aquatic genetic resources at the national level. During the open session for discussion, we welcome your experiences and recommendations and ways forward on the aquatic genetic conservation. Your inputs are very useful and valuable for us. With that, I now declare the webinar open. Thank you very much.
Thank you, Madam Secretary General. Before we start the first session, I would like to invite you all to turn on the camera to take a good photo, just quick one. So yes, please turn on the camera for the good photo, please. Okay. Turn on. Let me count 1, 2, 3. Right. Okay. 1, 2, and 3. One more, please. 1, 2, and 3. Okay, thank you very much. And yeah, before we start, and then we start the session, I will pass the floor to Dr. Warwick to facilitate this webinar. Dr. Warwick, please.
Thank you, Khun Wisarut, and welcome again to our webinar on fisheries genetic resources. Thank you very much for all resource person that we have today. Very good morning to you, sir and madam. And I think we follow the schedule, and as we circulated, we start with the FAO introduction. Just a moment. So this afternoon, we start up with the introduction and updates from FAO on aquatic genetic resources for food and aquaculture. We will start the first. There are 3 main presentations in this afternoon, starting from Dr. Graham on the state of the world aquatic genetic resources for food and agriculture and FAO response to its key findings, to be presented by Dr. Graham. And we will follow with the Dr. Danina on the global plan of action for conservation, sustainable use and development of aquatic genetic resources for food and aquaculture. And last but not least, Dr. Danila will continue her presentation on introduction of aquaculture and its application, presented by her. And I would like to request Dr. Graham, you have the floor to present. Thank you, sir.
Thank you very much. Can you hear me okay?
Really clear and loud. Thank you.
Excellent, good. So I'd like to thank the Secretary General, Mr. Smithri, for our welcome, and also I would like to thank CIFTEC for giving us this opportunity to reach out to a very important audience in the global aquaculture industry. I spent some time earlier in my career working in Southeast Asia, and it's nice to see some familiar faces, but also lots of new young faces of the next generation. So I would like now to share my screen. Can you now see the screen of my presentation in full screen mode? Wait a minute. Can somebody confirm that you can see a screen that says the state of the world?
Not yet in full mode, and I can see a slide on the framework.
Okay, I seem to have the wrong screen. Thank you, Daniela. Okay, how does that look now? Is that okay now?
Now, yeah.
That's okay. Thank you, sir.
Great. Okay, I will begin. So thank you very much for all sparing your time for our presentations today. And in this first presentation, I would like to set some context to FAO's work on aquatic genetic resources, and then Daniela will follow up with some more details about some of the specific resources that we are developing to support our members to improve the management of aquatic genetic resources. So both Daniela and I are with the Division on Fisheries and Aquaculture, and specifically we work within the aquaculture theme. But what we'll talk about today is the work that we do also under the auspices of the Commission on Genetic Resources for Food and Agriculture. And the overall objective of our work is to conserve aquatic biodiversity for food and agriculture and promote its sustainable use for food security, human well-being, and development worldwide. For current and future generations. So quite an expansive goal. The Commission, for those of you who may not be familiar with the work of the Commission on Genetic Resources for Food and Agriculture, this is the only international permanent forum that discusses and negotiates matters relevant to all components of biological diversity for food and agriculture. Obviously, within NFI, we work on aquatic genetic resources, and aquatic genetic resources has only really been an active part of the cycle of work of the Commission for the last slightly less than 1 decade. The Commission works under a cycle for its main sectors at the moment, that is plant genetic resources, animal genetic resources, forest genetic resources, and aquatic. They are now adding microbial to that, as well as generally biodiversity. So the typical cycle of work is that we start off trying to understand the status of genetic resources through generating country reports in response to an extensive questionnaire. We did this starting, I think, in about 2016 and received reports from 92 countries relating to the status of aquatic genetic resources. That included 9 of the CFTEC countries. So the CFTEC countries have always been actively engaged in this work. That information was synthesized into the State of the World report, which was published in 2019. We then developed a policy response in consultation with our members in the form of a global plan of action, and that was adopted by the FAO Council in late 2021, published in 2022. And this is where we are at now in the cycle for aquatic genetic resources. In the case of the plant genetic resources, they're already on the 3rd cycle, and animal on their 2nd cycle. So we're playing a little bit catch up, but very much the focus of our work now, and the reason why it's good to have this opportunity to speak with you today is that we're looking to enhance the understanding of the global plan of action, and for countries to look at implementing the plan, which is a voluntary code. But also as part of the cycle, we'll be monitoring the impact of that, and we already have the tool that can be used for that monitoring, which is Aquagris, which Daniela will talk about a little bit later. So what do we mean when we're talking about aquaculture and aquatic genetic resources? Well, I'm assuming that many of you are familiar with our SOFIA, the State of Fisheries and Aquaculture, and I'm sure that you're all aware of the importance of aquaculture, the current levels of production, which is over 90 million tons of animal production and another 35 million tons of algal production. We know this, and we know that that aquaculture is now equivalent to about half of aquatic food production. We also know, I think, and understand that aquaculture will be the principal driver of future growth in aquatic food production. And we all acknowledge that this growth must be done in a sustainable way. And we feel very much that effective management of aquatic genetic resources is one of the key components of sustainability in the growth of aquaculture. And so this is very much the focus of our work and what we will talk about today. Looking at the situation with CIFTEC member countries, again, you may all be aware of this, but I was updating myself, having not worked in the region for a while. You can see that there has been very strong growth until recent years, where there's been a leveling off in production. The region itself, or the CIFTEC member countries region, accounts for around 20% of global production. And given that we know that China dominates global production, the CIFTEC member countries, some of them are very important producers, particularly Indonesia, Vietnam, Philippines, and Thailand. So it's a very important region for sustainable aquaculture production. In terms of the genetic resources, if we look at our FAO production statistics, countries within the CIFTEC region are reporting around 200 species under production. But if we look at the key species, there are around 9 species which account for nearly 75% of this production. So there's a predominance of some species that includes the Euchema seaweeds, the white-leg shrimp, Vanamai, Gracilaria, Nile tilapia, striped catfish, and some other fish species. So there are already it's very clear that there are some very important genetic resources being used in the region and obviously globally. So when we talk about aquatic genetic resources, we're not just talking about the whole organism, but we're also talking about DNA, genes, chromosomes, tissues, gametes, embryos, and all life history stages of living organisms. And these can include strains and stocks and communities of organisms. The focus of the work that we do within NFI and within the Commission is focused on farmed species, but we also examine the genetic resources of those species where they occur in the wild, what we call wild relatives. So this is essentially a list of around 700 species that countries reported as being used in aquaculture. So I'd like now to just briefly summarize some of the principal findings from the first global assessment, which was published in the State of the World's Aquatic Genetic Resources for Food and Agriculture. As I've said, this is based on 92 country reports. These country reports represented 96% of global aquaculture production and actually also 80% of capture fisheries production. And it included the 11 major top aquaculture producers and also included 9 CIFTEC member countries, as I've already said. So we divide, as a result of the work that we did, we divide the important areas, the priority areas of aquatic genetic resource management into 4 subheadings. And these are the subheadings that frame the global plan of action that Daniela will talk about. So the first one is inventory, characterization, and monitoring of aquatic genetic resources with the goal of strengthening the global characterization, monitoring, and information systems. So the key findings from the report is that the standard FAO statistics, which you're probably all familiar with, which provide information on production of species, but it's clear that this gives us an incomplete picture. Not all species are reported in that system. Some of the production is actually reported in species groups rather than individual species, which means we know less about the genetic resource itself. And it was very evident that there is insufficient monitoring and reporting of genetic resources below the level of the species. There's also no system for recording exchanges of genetic material. And it was also very evident that there is a lack of standardization of nomenclature and ways of describing genetic resource, and this needs to be harmonized. So we're all familiar with the names that are applied to the aquaculture species that are, and farm types that are grown in our countries, but there is no standardized protocol for actually applying those names. Sometimes it relates directly to the genetic resource. Other times it has got nothing to do with the genetic history. So the first term to become familiar with is a term used to describe genetic resources below the level of the species. And that is the term we call farmed type. And this came out of an FAO workshop. This is a descriptor applied to farmed aquatic organisms at the level below the species. It includes strains, varieties, hybrids, triploids, monosex, and other altered forms, which we will discuss more specifically later on. Moving on to the second priority area, which is the conservation and sustainable use of aquatic genetic resources. And here it became evident from the report that non-native species are extremely important in global aquaculture. There are around 200 species that are farmed as non-natives, in other words, in countries that they are not native to. And we're also aware that culture of non-native species may represent harm to indigenous biodiversity. In some cases that harm is documented, but in many cases it's not. It was also recognized that wild relatives are very important in fisheries, but are also in decline in some areas, sometimes due to overfishing. Both in situ and ex situ conservation need to play a critical role in the conservation, long-term preservation of these genetic resources. This can be in the form in the wild of aquatic protected areas. Both aquaculture and managed fisheries themselves are forms of conservation, especially when well managed. And we also documented in the report ex situ, in vitro, and in vivo gene banks. And there are quite a lot of those, but nothing like the scale that occurs in livestock and plant. Danielle and I recently, after producing the State of the World report, we did a closer analysis of the conservation of aquatic species. We know that unlike in terrestrial aquaculture, all species that are currently farmed still exist in the wild, whereas many of the originating species for terrestrial agriculture are now extinct. Does this mean that actually aquatic biodiversity is in good condition? We investigated using the red list, the IUCN red list, and also the CITES conventional international trade lists of controls for species. And we did this just for aquaculture species. We looked at over 441 species, and we found that there was a relatively small percentage that were classified in the critically endangered, vulnerable, and near threatened categories, but not completely insignificant, as you can see in the table there. But if you look at the production volumes in aquaculture, we found that something like 17% of aquaculture production is of species that have some level of threat as classified by IUCN. And there are some quite well-known species that are very important and cultured in large volumes that are actually already under some level of threat in the wild. And many of you will be familiar with these species, for example. Looking at the domestication of farm species, we know that aquatic species were domesticated relatively recently. Many species over the last 3, 4, 5 decades, and almost all species were domesticated within the last 100 years. This compares to terrestrial animals and plants which were domesticated 5,000 to 10,000 years ago. As a result of this, the levels of genetic diversity we find in aquaculture in many cases are comparable with those found in the wild, whereas a lot of genetic diversity has been lost in terrestrial species. This means that these species retain the adaptive capacity and also retain the potential for genetic gains from selective breeding. And we know that if we look at the typical gains occurring from selective breeding, in plant breeding, it's quite common that a selective breeding program will generate yields of 1 to 2% genetic gain per generation. In livestock, 3 to 4%. In aquaculture, it's quite achievable to have 10 to 13%. So we have this potential because we still have a lot of the genetic variation, but it's vital that we retain and start managing that genetic resource very effectively now before this window of opportunity and genetic variation is lost. Unfortunately, through the report, we recognize that there is very often a lack of attention to genetic management in many aquaculture systems. Poor genetic management can include the development of hatchery stock using inadequate founder stocks, breeding from one generation to the next with small effective population size, using few broodstock, having an unbalanced sex ratio, and also in some cases having uncontrolled hybridization where hybrids are produced, but then the F1s enter use as broodstock. The consequence of this is that we see genetic drift, we see loss of alleles, particularly rare alleles, also changes in frequency. We see inbreeding and we see unplanned hybrid introgression, which from an aquaculture potential leads to a loss of adaptive potential, declining performance over time, a reduced response to selection, and in the case of introgression, a loss of species purity. So these are problems that need to be addressed, and they are through the Global Plan of Action. If we look now at the third priority area, the development of AQGR for aquaculture, the goal here is to accelerate the development and uptake of genetic improvement. But how impactful is genetic improvement? I think we all know of examples of genetic improvement, but just a decade ago, studies in the literature indicated that less than 10% of global production was based on selected animals. And this compares with terrestrial agriculture where it's close to 100%. So we are missing an opportunity. I think we see today that there is good progress in species such as salmon, where the entire global production is of genetically improved selected animals. And Vanamai shrimp culture is increasingly of genetically improved animals. But there is limited progress in other major production species, particularly lower value species in the developing country areas. The State of the World showed that, report showed that around 50% or 45% of the farm types being grown in aquaculture were classed as wild types, so no different from wild genetic resources. And also when countries were asked if selective breeding is impacting on production of aquaculture in their countries, 45% basically suggested that it was not impacting in any significant way. So clearly there is an area for growth and a huge opportunity to advance our production and our adaptation through more selective breeding. Why is selective breeding being adopted relatively slowly in aquaculture? We asked the question, do we have a balanced research and innovation process? Are we actively investing in some of the baseline areas of selective breeding and heritability estimates? Is there a lack of appreciation of the scale of benefits that can arise from breeding programs? Sometimes there is a focus on short-term public sector programs, whereas genetic improvement must be long-term. There is a perception that programs must be large and resource intensive, and there is no option for smaller, cheaper programs. There's a lack of private sector engagement, especially for low-value species, and there are challenges in protecting the results of selective breeding, which limits investment because people feel that it cannot protect the intellectual property coming from the breeding programs. There are concerns over the negative genetic impacts of escapees, of selected animals, plants, and then there's a lack of human resource and infrastructure capacity. So all of these reasons are contributing to the slow adoption of genetic improvement and need to be addressed. Moving on to the last policy area of policy institutions and capacity building. This is a very complex area. I won't read out all of the factors in this chart, but there are many factors that have to be considered in the development of policies that impact upon the management of genetic resources. They are many and complex, and we need to deal with those, but this is not a reason that they should not be addressed. Where we do see policies that include aquatic genetic resources, they typically only address resources at the level of the species and not at the level below the species. And also where policies and management plans do exist, they are often ineffective due to the lack of human and financial resources to implement and enforce policies. So there's a lot that can be done in the policy and governance space also. So just in winding up, What FAO has been doing in our program of work here is that we have been producing a few resources. Key amongst those was the global assessment, which I have summarized here. But in response to that global assessment, we have developed an information system called Aquagris, and also the policy response in the form of the global plan of action, which Daniela will talk about. So I would like to end there. I believe that we will have opportunity for questions after the 3 presentations coming from FAO. So I would like now to just stress that we are at the point where we have produced some resources. Countries through the FAO Council have adopted the voluntary global plan of action. So now we are focused on communicating and working with countries to take action to enhance the management of aquatic genetic resources. So I'd like to thank you for your attention. We will be sharing these presentations, which will include our contact details and our links to our various resources. So thank you very much, and I will stop sharing my screen and hand over back to the chair. Thank you.
Yeah, thank you very much, Dr. Graham. Very comprehensive information that we received from introduction of the stage of the world aquatic genetic resources for food and aquaculture. I think you can see a long story of developing this program under FAO Global Action Plan. I think the next presentation would give us further more detail on global action plan and what countries should prepare and cooperate with FAO in order to fill in and put in information regarding the requirements based on the global program on that. Thank you very much once again, Dr. Graham. I think before that I would like to request FAO, if you allow, all of the video record of this webinar, can we share with our member countries later on, Dr. Graham?
Yes, sure, fine.
Okay, very good. And I think we go to next presentation by Dr. Danlila on the global action, global plan of action. Please, the time is yours. Thank you.
Thank you, Secretariat, and good afternoon, everyone. So I'm going to share my screen. Just a few moments. Okay, should be screen. Can you confirm whether you see the presentation in presentation modality?
Yes, perfect. Dr. Danlila, please go.
Okay, thank you. So first of all, yeah, I join Graham in thanking you for the opportunity to tell you something about the work of FAO on the QGR. And especially it's very important to communicate what we do to such an event, regional event, and the most important region for the aquaculture sector. So as anticipated by the Secretariat, this first presentation of the 2 presentations that I will deliver is about the global plan of action for the conservation, sustainable use, and development of the aquatic genetic resources, AQGR. So, okay. So briefly, during this presentation, we will see what is a global plan of action in the context of FAO's work, what are the objectives of this very important policy document, the process of development of the GPA, the structure, and finally, I will talk a bit about implementation and monitoring mechanism of the GPA. So what is a GPA, first of all? A GPA, a global plan of action in the context of FAO's work under the Commission on genetic resources, is a framework to promote international cooperation for a wiser management of the AQGR, in order to make important contribution to food security, sustainable development, and the alleviation of poverty. The development of the GPA was something requested by the members of the Commission on Genetic Resources for Food and Agriculture. And I would like to stress the fact that we were the only sector that still didn't have a GPA at the time that request was made, because the other sectors, the other food and agriculture sectors, so the livestock, the crop, and the forestry sectors, they had already produced their own GPAs and related mechanisms for monitoring its implementation. So it was time for us to move on in this sense. So the GPAs has many objectives, including the protection of habitats and wild populations, the promotion of equitable access to AQGR, and the equitable sharing of the benefits deriving from the utilization of these resources, to raise awareness among countries and stakeholders on the importance of AQGR to food security, to support the appropriate utilization of technologies for the development of the AQGR, the development of voluntary guidelines and frameworks for improving the management of these resources, and so on. And in terms of process for the development of GPA, so everything started in February 2019, when the FAO members, so the countries members of the FAO Commission on Genetic Resources, requested the organization to develop the GPA. And because the GPA was requested by countries and is for countries, we developed this document through a series of regional consultations, 5 regional consultations in total. And the draft version deriving from those consultations was then negotiated by the ITWG, which is the Intergovernmental Technical Working Group on AQGR, a very important body under the umbrella of the Commission. The negotiated version was then endorsed by the Commission and finally adopted at the end of 2021 by the FAO Council. The GPA is considered a rolling plan with a time horizon of 10 years, which means that usually should be updated every 10 years. And in response to the FAO global assessments on genetic resources. So Graham has presented the findings of the first state of the world, the first global assessment that we produced in 2019. The current GPA is a response to the needs and challenges identified by that global assessment. And the next state of the world should be produced around, there's not yet an agreed timeline, around 2029. So there will be a new GPA that should follow that second assessment. And very important is the fact that, yes, the GPA was requested by countries, but countries are not, don't have any obligation actually to implement the GPA. So the GPA is completely voluntary and non-binding. And I've put the link to the publication in this slide, and you will find the GPA not only in English, but also in the other UN official languages. The GPA consists of 4 priority areas of work, namely on inventory characterization and monitoring, on conservation and sustainable use, on development of the AQGR, and on policies, institutions, and capacity. And I really invite you to have a look at the publication. And if you open it, you will see there is a first part with an introduction to the GPA that explains the process of preparation, the rationale behind its development, the objectives, the structure of the GPA. And then there is a second part, the most important one, which sections for each priority area of work. And for each priority area, there is a long-term goal for that area and associated strategic priorities identified for that area. And within each strategic priority, there is a rationale, the goal for that strategic priority, and the number of actions associated with the strategic priority, for a total of 21 strategic priorities and almost 100 recommended actions. Of course, the consultation around the GPA was a global consultation with countries all over the world, but countries and regions can have different priorities in terms of strategic priorities and actions that should be undertaken for a better management of the AQGR. Examples of recommended actions. So under the first priority area, we have the need to strengthen national regional monitoring systems on AQGR and to establish long-term funding mechanisms for global information systems, but is also recommended, for example, under conservation, to identify those stocks that are at risk and to promote the adoption of genetic technologies in stock assessment and management. And again, under the third priority area, for example, a recommended action is to develop online materials, online resources to promote a wider adoption of genetic improvement. And under, for example, the last priority area of work is recommended to develop and support gene banking networks and to promote implementation and the application of international agreements. Okay, so of course, when it comes to policy strategies, it's very important to have monitoring systems to monitor the progress in implementing that policy and the strategy, and the GPA is not an exception in this sense. So we have also developed a monitoring system, which is based on two types of indicators: resource indicators and process indicators. The resource indicators serve to monitor the status of a QGR directly, and these indicators will be integrated into Aquatic, that is the information system I'm going to talk about in the next presentation. The process indicators are related to those actions undertaken by countries to implement the GPA. And this will be measured through a separate standalone questionnaire that will be submitted by to countries, and it's something different from the Aquatic questionnaire. So in total, we have developed 24 indicators, resource indicators, and 23 process indicators. And the reporting on the resource indicators will be every 2 years, whilst for the process indicators, every 5 years. And okay, before concluding this part on the GPA, I would like just to mention a few examples of countries that have started to take action in implementing the GPA, and that are Indonesia and Chile. And I'm happy that we have also Indonesia representatives today here. So with Indonesia, we have started a technical cooperation project because the country had requested FAO assistance in developing a national strategy for the sustainable management of the QGR. So the project has just started. And Chile has embarked in a project also because the government wants to develop its own strategy for a better management of the QGR, and they are using the GPA as a reference to develop their own strategy. And with this, I've concluded this first presentation, and I give the floor back to the Secretariat to recommend if I can move to the second presentation or less. Thanks.
Yeah, yes, thank you, Dr. Danila. I think you can continue. I think this continue presentation will be better for our understanding, if you okay.
Yeah, I'm okay. So fine, and let me give me only a few moments to share the other presentation. Share, yeah. Okay. Okay. Yeah. Okay. Do you see my presentation correctly in presentation
Yes,
modality? Okay,
yes,
perfect.
Yeah.
So yeah, second topic is Aquagris, where Aquagris stands for Aquatic Genetic Resources Information System, and it's a completely new tool, a new information system of FAO dedicated to the aquatic biodiversity used in aquaculture. And okay, and so we will see what Aquagris is in details, why we have developed this information system, and how Aquagris is structured, and what are its functions, and its possible applications, and where we are in terms of development. So Aquagris, as said, is an FAO-hosted information system which aims to collect, organize, and make publicly available information on those AQGR below the level of species, particularly FAR types and wild stocks of aquaculture species. You have in this slide the link to the current version of Aquagris, which is only a prototype and has very limited information compared to the information that will be available in the future with the new version of the information system. Why the development of Aquagris? So, like in the case of the GPA, Aquagris development was requested by the FAO members because the preparation and the publication of the State of the World had to raise the awareness on a number of issues, including the fact that in terms of global characterization, monitoring, and availability of information systems on aquatic biodiversity, we have very limited capacity at national and global level. And in addition to the lack of characterization and monitoring of AQGR, especially below the level of species, so when it comes to FAR type and wild stock level, we also realized that there are sometimes inconsistencies within countries in their respective mechanism to report information on what they farm. So, for example, at the time of the preparation of the State of the World, we noticed that for the State of the World preparation, countries reported to, in total, to farm almost 700 species. But at the same time, in the FAO database, in FISTA-J, which is the database where countries report every year information on their production statistics, there were less than 500 species reported for the aquaculture sector. And another important point was, and is still, the fact that there is often a misuse and not a common understanding of the terms used to identify and to describe the AQGR, especially at farm type level. And in addition to this, I want to stress also here the fact that compared to the other sectors, we were behind in terms of availability of information systems, because, for example, the crop and the livestock sectors, in the past, they have already established their own global databases, which are both maintained by FAO and are used for the crop sector and DADIs for the livestock sector. These databases, they collect data for thousands of cultivars, thousands of breeds, and there is information associated with each cultivar and with each breed in terms of the characteristics of these genetic resources and also the status of conservation. And another important aspect is that through these, I mean, these are the two information systems, the two tools through which the international community can measure progress made towards target 2.5 of the 2030 agenda. Target 2.5 is the one dedicated to genetic diversity in food production. And there are two indicators under this target, but they are only for plant and terrestrial animal genetic resources. So there's no indicator dedicated to the QGR. And the main reason is the fact that we didn't have, I mean, before now, an information system, so a tool to measure the progress towards the achievement of this target. So we are also hoping that Aquagris will be a driver in the future to develop indicators in the context of the Agenda 2030. Now, I would like to spend some time on this slide because it's quite important in the sense that before starting the development of the information system, we started, first of all, with the development of a classification of far types, because the focus of Aquagris are far types and wild stocks of aquaculture species. And in the first phase of the project, our attention focused only on the far types. But it was critical to develop a classification to adopt into Aquagris, but also classification to widely distribute, to widely promote, to start promoting a standardization of the language in the aquaculture sector. So we met with the group of experts and we established this classification, which is based on 11 categories of far types. And Graham has already provided the definition, but I'm going to repeat it now. So a far type, which is a relatively new term, as any aquatic organism that can be found in aquaculture and can be a strain, a variety, a hybrid, a monosex far type, a gene-edited organism, and so on. The classification distinguishes two groups of far types: primary far types that are that represent the different stages in a domestication continuum, with at one end of the process the what we call the wild source far type, which basically are seed and broodstock collected from the wild. On the other end, you have strains and varieties, where strain applies to aquatic animals and microorganisms. Variety is a term that applies to aquatic plants and microalgae, so to seaweeds, basically. And the stage of strain and variety represent the end of a domestication continuum and the result of a domestication selection process or a deliberate genetic improvement program. Whilst everything falling in the between is called captive propagated, which means that the far type starts to be different from what you find in the wild, but not yet differentiated at the level of a strain or variety, because a strain or variety has something that has distinguishing characteristics that allow to distinguish that strain or that variety from other similar strains and varieties of the same species within the specific country. The secondary far types are those far types that are derived by one of the primary far types. So when we started the development of Aquagris, so yeah, we developed the far type classification. We also developed the initial questionnaire for data collection into Aquagris that we have refined later and will be updated in the new version. But anyway, in the first part of the project, when we developed the prototype information system, we conducted also a field test of the classification and the questionnaire through a data collection at national level in the Philippines, and through separate data collections at species level, species and fact type level, for a group of important species in terms of commercial production worldwide. And so we work with a group of experts, including Dr. Wen, that will present later, and will give you some idea of her experience in this regard. Aquagris, the new version will be released by the end of the year, and will contain data, so data coming from different resources, data from the production statistics database of FAO, data from the database of the state of the world, and then the most important one will be represented by those data collected through the Aquagris questionnaire, which were developed in two forms: an online version and an Excel-based questionnaire. And the online version is more user-friendly in my view, but the Excel-based questionnaire can be useful for collecting data if you are interviewing the people that are the sources of information. The persons that will be in charge in the future to collect and especially to validate the data that will populate Aquagris will be the national focal points for a QGR, but national focal points can decide to nominate experts that can help in the data collection phase. So, well, only the national focal points and the possible experts nominated by them will have access to the questionnaire, to the online interface for data entry. Whilst there is also, and there will be an interface for data query that will be available to any user, and at the moment is available in reality from the FAO website, but only in the prototype version, which, as I say, there's still very limited information. But it's nice. I mean, the interface for data query is nice because it allows to filter data by geographic level, by taxonomic groups, by species, by fact types, and it gives also the possibility to generate reports at country level, at species level, and in the future also at fact type and wild stock level. Aquagris applications. So, of course, before starting the development of Aquagris, we started also with identifying those stakeholders that will most benefit from having access to such an information system. And so Aquagris was mainly designed to address the possible needs of government resource managers, policymakers, aquaculture producers, scientists, and international organizations. And these stakeholders can use Aquagris in a variety of ways, like to develop national strategies, to prepare national reports, to have access to, this is especially for producers, to have access to data on fact types, and so where a fact type is produced, what are its characteristics, and again, Aquagris can provide information for the development of R&D roadmaps for research and publication purposes, and can be an important knowledge repository to provide scientific advice to policymakers. And I don't know if we still have time, maybe because I don't know, maybe the Secretariat can advise if there is still some time to make a short live demonstration of the online questionnaire of Aquagris, or if we are running out of time.
Yes, thank you, Dr. Daniela. I think you can demonstrate. No
Okay,
worries.
thank you. Okay, thank you. Thank you. So, okay, no, give me a moment. Can you see the website?
Yes, I saw it.
Okay, so perfect. So in the future, national focal points, where will we start the official data collection? So the national focal points will receive their own credentials and will have access to their account, Aquagris account, to respond to the online questionnaire. So at the moment, I'm just demonstrating a test account, and okay, test. Okay, so okay. So the questionnaire, the Aquagris questionnaire, consists of different sections. There is a section with basic information at species level, where the person in charge of reporting information will enter the name of the country, the taxonomic group of the species name, I mean the scientific name, the common name, whether the species is native or less from that country, information on the risk assessment conducted in the case of introduction of the species to the country. There is a question on possible risk associated with the introduction of the species in terms of impacting on indigenous biodiversity, a question on climate change impact on the species, both the wild stocks and the farm types. Then there is a section dedicated to the aquaculture information. So the questionnaire asks what is the main purpose for farming the species. And I didn't say that there are guidance notes to help users to fill the questionnaire, but we will also develop a separate document, separate guidelines that will accompany Aquagris. But coming back to the aquaculture related information section. So yes, as I said, the first question is about the main purpose of production. And then there is a question on the most common culture system used to produce the species. And this is an open-ended question. There is a section on production statistics, where you can report information on the production volume, the production value, and your reference for those statistics. There is a question on production trends. Then there is a last question in this section asking whether in your country there are farm types for that species, and here you can report the list of the farm types. Initially, the system allows to report only primary farm types, because the secondary farm types are reported at the end of the primary farm type sections. So, for example, if you, I had entered an example of a primary farm type. So, if you click on it, the website will open a new section with a fact sheet on the primary farm type. And here again, a number of questions related to that primary farm type, like an open-ended question where you can report a brief description of the fat type, the name of the person providing that information, the type of the primary fat type, whether it is a strain, a variety, a captive propagated, a wild source fat type. There is a question asking the estimated production of that fat types in terms of contribution to the national production of the species to which the fat type belongs, current trends, origin of the fat type, risk associated with its use, composition, whether it is a pure species or if it is introgressed. And there is information that you can report on whether in this case, we are talking about a strain, whether the strain is the result of a domestication selection process or selective breeding, which selective breeding techniques were used. And then, for example, there is a part where you can report whether the fat type has distinguishing characteristics that can be genetic, qualitative, phenotypic characteristics, performance characteristics. You can provide here more detailed description of the distinguishing characteristics, the source of information, whether the fat type is subject to conservation measures, and whether the fat type is exported to other countries. And here there is the section where you can list possible secondary fat types that are produced using that primary fat type. Of course, we don't have time to see everything, so I will not demonstrate also the secondary fat type section, but I want to go back quickly to the part on the wild stocks before concluding. So yeah, the final part of the questionnaire is dedicated to wild relatives of aquaculture species. And here the questionnaire asks, if the species is also harvested from the wild, the current trend of the harvest, the main type of fishery, so for example, industrial fishery, artisanal fishery, the status of habitat and of that species, if it is increasing, stable, decreasing, or not known, if the species is reported in a national red list that is based on the IUCN criteria or on a similar list, and whether there are management or assessment units for that species in your country. And there is a last question, and here you can list the management units that eventually exist for that species. And here there is a last section about genetic stocks of that species in your country, where a genetic stock, this is also something that we define with Aquagris, and we coin the definition with a group of experts. Also in this case, a genetic stock is a stock that has distinguishing characteristics that distinguish that stock from other similar stocks of the same species within your national jurisdictions. And these characteristics can be genetic, of course, but can also be phenotypic characteristics, or can be other characteristics used as proxies of genetic characteristics, like geographic isolation, specific adaptations, the different composition of the parasitic load of the different stocks. And yeah, with this, I will, I don't think we have time to go through the section on the genetic stocks, but yeah, I will conclude here and will give the floor back to the Secretariat.
Yes, thank you, Dr. Daniela. I think we have a number of questions here and there, but
Okay.
I think most of us are very new to FAO global program, global action, and also this questionnaire online survey initiative. I think later on, if we see in the list of our agenda, we have another session on the short introduction to the online training. Is that online training program is meant for the for the online questionnaire. Is my understanding correct?
No, the online training program is a training program we developed with a partner to about genetic management and genetic improvement of aquatic genetic resources. But we are running training programs and will be running training programs on aquagris, because we very much understand that it's not really feasible to use the questionnaire without receiving a training first. I mean, there are help functions, and we will be writing a written guideline to accompany it. But there are some elements that need to be well understood, particularly how to classify farm types and genetic stocks. So we don't expect any national focal point or any nominated expert to enter information without receiving a training. So over the next year, we will be offering trainings, and this can be one of the things where we can discuss at the end of today's session as to whether we can find a mechanism to do a training for CIFTEC member representatives on the actual use of aquagris.
Okay, thank you, Dr. Graham. I think very clear. I just have very important question to the floor. You mentioned that this global initiative is non-binding and voluntary basis. So how the global initiative of this program is to ensure the input from the country, because you said this is voluntary and it's not that kind of big challenge, if you need inputs from the country, but you said this is the voluntary.
Yeah, when I say it's voluntary, I refer specifically to the Global Plan of Action. So, I mean, the Global Plan of Action was developed by FAO upon request by countries, but then it will be with the countries the final decision to integrate the GPA into their already, for example, existing national policies and strategies, or to develop a new policy strategy using the GPA as a reference. So what FAO is doing from its side is to widely communicate the fact that now the GPA is available, was adopted at high level because it was adopted by the FAO Council. So it's now time to move to the new phase of implementing the GPA. And at the same time, of course, we are developing all these other tools like aquagris in premise, because of course, these tools are fundamental to support countries to implement the GPA.
Yes, thank you for that clarification. I think
Yeah.
I leave the questions, a few questions, and from the floor, our member countries. I saw the comments from the chat box from my colleague, Malaysia, maybe the same concern of having challenges in terms of reporting this GPA by the country. Is there any other questions? If none, I have few questions to ask. I heard from Dr. Graham that you said this is just, now we have only the first cycle of the program under fisheries or aquatic genetic resources. What the full cycle I would like to see, the cycle starting from developing a prototype, what I understood, and then you are now waiting for the nomination of national focal point, and then start the training program, and then getting input from the national focal point, and then analyze, and then report, and some sort like that.
Yeah, we
Right.
work very closely with countries through national focal points. So at the beginning of the whole process years ago, before we started the State of the World, all member countries were asked to nominate a national focal point. And actually we have 9 countries within the CIFTEC region have national focal points. We don't have a national focal point for Vietnam and the Kingdom of Brunei. And so if there's any representatives here today, we would very much encourage you to nominate a national focal point. And now that we have done the work and with the support and consultation with national focal points to create the policy document, which, as you discussed, is voluntary, it's now the challenge. We assume that most countries would like to commit to improving the management of their and development of their aquatic genetic resources, but sometimes there are other priorities and their resources are limited. We at FAO are willing to support activities wherever possible. So at the moment, Daniela mentioned the TCP with Indonesia, we are supporting that. But we reflect back that 92 countries were willing and able to provide country reports to support the first State of the World report. What we hope now is that that process will become a little bit easier because a lot of the reporting now will come through Aquagris. So rather than spending a lot of time completing a very comprehensive questionnaire every 10 years, once we can get information into Aquagris and we consider that information and to create a national registry as being an important first step to improving management of AQGR in countries, we want to now support over the next 2 or 3 or 4 years for as many countries as possible to learn how to use Aquagris. We will be running trainings and we will support countries as far as possible because Aquagris is nothing without data from countries. So ultimately, we would like to see all of those 92 countries actually creating national registries within Aquagris. We understand it's quite an important and time-consuming exercise, but creating it in the first place is time-consuming. After that, I think updating it every 2 years should be relatively straightforward.
Okay, thank you, Dr. Graham. For after listening from you, I think the cycle or the process of this program is first the country input information in the online questionnaire, and then the result or outputs from the online questionnaire will be accommodated and insert or input to the Aquagris that you mentioned.
The questionnaire is part of Aquagris, so as soon as the information is uploaded through the questionnaire that Daniela demonstrated, we then ask the national focal point to validate that data. It's then uploaded into a database which can then be accessed through what we call the data query user interface. And that's publicly available, and anybody can then generate a report, for example, an indicator report or a species report or a country status report. And so once the information is uploaded into the registry, we can generate reports in many different forms using the data entered into the system. And ultimately, every 10 years, we will use that data. So we anticipate the next State of the World will be 2029. We will use the updated information in Aquagris then to contribute to that State of the World report. So it will be much easier to generate the next State of the World report if countries are already using Aquagris.
Wow, very fantastic. I think I see the flow of work that now being developed and implementing with the countries. Very excellent job, I think. I think we can come back to the question answer session again if country has anything, but we rather listen to our resource person, Dr. Maria, Dr. Weng. She will join us the story of national experiences from the Philippines inputting data in the system. Maybe you have the floor, Dr. Weng.
Yes, thank you, Dr. Worawit. I hope I can share my slide. If I can be made co-host. Okay. So, can you see the presentation?
Yes, very good. Thank you. Go ahead.
Okay, thank you. So today I'll be sharing my experience in collecting data as well as entering data in the early phases of the Aquagris. Okay. So as you can see, the species that I was asked to work on is the milkfish. Right. Okay, so this would be the content of the presentation. It's a brief presentation, and I think like much of it has been discussed by Dr. Graham and Dr. Daniela. So project introduction, preparations, introduction on the assigned species, the industry overview, importance of the Milkfish Genetics Resources Registry, and the method for data gathering, as well as the survey output. Yeah, so I think earlier on we've heard Dr. Graham and Dr. Daniela discuss about the GPA, so I won't dwell much on it. They're the ones who really led the project that is under this global plan of action. Okay, so in June of 2020, that was during the pandemic, I think, no? The FAO had this regional workshop for Asia and the Pacific region on the development of a registry of farm types of AGRs. So I was part of it. If people from CFDEC are quite familiar with me, I used to work for CFDEC. I retired early in the year. I now am with the academe. So you can see my picture there. I was asked to attend together with the other experts from the region as well as from FAO. So the purpose for that workshop is basically to establish the national and global characterization, monitoring and information system for the aquagris, develop, promote, commercialize, institutionalize the standardized info systems. And the coverage of this info system is essentially to collect, validate, monitor, and report on the aquatic genetic resources below the species level. So as discussed by Graham and Daniela, those are the farm types and the stocks. Okay. So I was asked to look into milkfish or Chanos chanos. This is the only living species in the family Chanidae. It's globally important. It's the second among the major marine fish species. And as reported in 2020, the production is around 14% of the total marine aquaculture output. This is based on FAO 2022. So it's a preferred food fish in Southeast Asia, in particular in Taiwan, Indonesia, and Philippines, and I think also in Thailand, no? Where basically in Taiwan, in those three countries, it has been bred in captivity since the early 80s. And it has been reared up until now in diverse farming systems, from freshwater, brackish water to marine farming systems. In other countries, the fingerlings of the milkfish is used as bait for catching tuna. Okay. Okay, so as an industry overview, as mentioned, this is primarily a food fish, but it's also important as a bait for the marine capture fisheries industry. So I mentioned here some of the industry status, like in the Philippines, production, the demand for seed stock is such that the Philippines has to import seed stock from Indonesia, as you may well know. So it's around more than 50% of the seed stock that are grown to adult sizes in the Philippines for commercial production comes from Indonesia, apart from wild sources in the Philippines. So Indonesia, on the other hand, of course, they're self-sufficient. They produce their own seed stock. And these are locally sold and exported, as mentioned, to the Philippines and to Malaysia as well, for on-growing to adult sizes. And then it's exported to Pacific Island states and Singapore for the fingerling production as tuna bait. In Taiwan, they are well into integrated commercial milkfish hatchery and nursery operations. And they also engage in intensive farming, both in earthen ponds and elevated tanks. So that's how important milkfish is in the region. Okay. So as genetic, how important is information coming from this particular species to be part of that genetic resources registry? So we all know that any fish that is produced, both in aquaculture in particular, if we want good quality stocks or fish for production, which would have economically valuable attributes. It would all depend, as we all know, from the source, no, where we got those seed stocks from, the origin of the fish, also the husbandry or breeding and on-farm management schemes that are used for propagation. So if at all we have a registry, it would be easy for us to get information on the genetic background and the economically important traits of farm types. And then knowledge of the history of those stocks and their genetic makeup would also be important, and it could be accessed by way of a registry. Okay. So all of this information, if at all, if you're doing research or if you're in the milkfish production industry, we can use this information if we try to get into selective breeding or if we want to further improve the stocks that we grow. Okay? And so with the registry, as mentioned by Dr. Daniela, it can help farmers, aquaculturists, researchers, even conservationists. No? If they have access to data, it's important for conservation, management, stock improvement, and also traceability. Like, for instance, milkfish in the Philippines. If we want to grow fish in farms and we couldn't get, we do not have easy access to seed stock, normally the stocks would come from elsewhere, no, not within the same region. So that's important for, like, if you want to have information on traceability of the stocks that we grow. Okay. Okay. So next, what was the methodology that was adopted when we gathered data? So as I mentioned, in June 2020, we had that online workshop. So we were oriented. We were told what the purpose was, what the use of the registry was for, what information was needed to be uploaded into the database. And in the same workshop, we discussed the survey questions. Many of those have been shown to you by Dr. Daniela, and all of us were guided on access to the survey questionnaire. So next step was to provide the data gatherers, that includes myself. So we were provided a list of the national focal persons in all of the countries that are involved. And then we went on to start with the survey. I contacted the national focal person in the Philippines, who happens to be Miss Jude Danting. I think she's around in this webinar. I tried to contact her and all of those in the other countries where the milkfish are farmed or are naturally occurring. So I communicated with each of them. Fortunately, in the Philippines, the Bureau of Fisheries and Aquatic Resources was quite supportive. So Ms. Danting referred me to, there is a technical lead person for particular species that are farmed in the Philippines. And so for milkfish, that happened to be the regional director, Willie Cruz. He and his staff were quite helpful. No, they're quite helpful in the sense that I didn't have any problems accessing information within the Philippines. Okay, so from thence, we distributed survey questionnaires to those respondents, and those respondents, the addresses, the contact information was provided by the national focal person, apart from the regional director, who's also the technical lead person for that particular commodity. So I emailed those people. I think what I used back then was just the Excel file, or the Excel, or it's a document, electronic document that we can send by email. So the survey was completed via email exchanges, because back then we had travel restrictions because of COVID. And then after the data gathering was the data uploading part. So back then we were told to use a tentative platform, which was Survey Solutions. I think now the more robust platform that has been introduced to us. I happen to have attended the training, and also I think Miss Jude and some of her colleagues also attended the training on the use of the Aquagris So fortunately now it's quite easy to get information into that platform. Okay, just to show you the kind of information, sorry, this next slide shows us the different farms where I got information from when we did that milkfish survey. So as mentioned, we identified countries where the milkfish are farmed or naturally found. So we have there Philippines, Indonesia, Malaysia, Papua New Guinea, Sri Lanka, Tanzania, and Tonga. So from out of all those 7 countries, I got most of the information from within the Philippines. So we gathered data from 6 government hatcheries and 8 private hatcheries, and that included SIFDEC Aquaculture Department, which has the oldest milkfish in captivity. And then Malaysia, there were 3 private farms that responded. So they gave us information on the stocks that they have. Tanzania as well. For the other countries, unfortunately, we weren't able to get any information from Indonesia back then. I tried several times with the help of Dr. Graham. And then Sri Lanka also no response. Tanzania had 1 private farm. Okay. So don't be overwhelmed with the fine print there, but this is just to show you the spreadsheet that I use, no? So each of the sheets would contain information from each of the countries where I got data from. So from the Philippines. So if you recall the questions in that online platform showed to you by Doc Daniela, so most of those that have entries here are basically the questions, the same questions that are found in that online platform. Only this, at this phase, we used the Excel sheet as well as the doc file. So I tried to just summarize all of the information that I gathered. Okay, this slide shows us that apart from, of course, getting data on the ground, it would also be very important to validate the information that we get. Okay? So apart from the actual stock survey, it is quite important to consider additional references like maybe population genetics data if available, data on fishery management units, and that way we will be able to accurately classify the populations that we're examining into what farm types, the primary farm types like the wild caught farm type or the captive propagated type, or if there would be genetic stocks or improved strains, then we can classify them accordingly based not only on the actual data coming from the respondents, but also from published information, scientific information. So what I'm showing here are 2 papers on the milkfish, one of which is a publication that I had on the milkfish stocks, which we examined using microsatellite markers. So the map up on the right-hand portion of the slide here are the areas where we got the stocks from. And the paper that is shown, or the title of the paper shown below by Santos et al. Examine the same stocks, but using different markers, mitochondrial DNA markers. But both papers point to the fact that in this study, what we did was to look into hatchery stocks as well as wild stocks. So the main highlight of those papers is that there was significant but low genetic differentiation amongst the stocks. And apart from the Philippine stocks, I failed to mention that we also got a stock from Indonesia, because of course, as I mentioned, some of the seed stock that are used in the Philippines are imported stock from Indonesia. So we were able to get a stock from Indonesia by way of the local source. And then in the paper by Dr. Santos, it's the same observation. So he found weak genetic structuring amongst the population. So what does this indicate? It indicates that it is possible that the Philippine wild stocks of the milkfish just belongs to one panmictic population. So that's important information that one should use in classifying the data that is gathered on the ground. Okay, so this is an example on the milkfish. There are other papers as well. No? I'm sure in Indonesia, there would be studies, genetic studies on the milkfish. This one is a paper on mud crabs. So basically, it's information coming from a genomic study. So here, this is a paper by Shrestha et al. I was also part of the team that looked into 3 populations of the mangrove crabs in the Philippines. So what was the study about? It was about looking at any differences between those stocks, no? As they respond to heat stress. So we examined the stock coming from the western part of the Philippines, that is in Bataan, and then 2 stocks from the northeast part of the Philippines, that is coming from Cagayan and I think Bicol. Yeah. So a comparison of those, looking at transcriptome profiles, we saw some differences. No? So if at all, preliminary information on such studies would be available. And if a survey on the mangrove crab stocks would be included as well in the registry, then we have to take note of this particular information. So here, as mentioned, there was a difference between the crab populations. So the west stock was actually more, what they call this, when it was exposed to heat stress, it was more resilient based on the profiles that we got as compared to those coming from the northeastern stock. So if at all we would consider, if we gather information on farm stocks, we could classify them as 2 primary farm types, west and the northeast stocks of the crabs. Okay, I think this is the last slide that I have. Okay. So I think we have to take note of those resources as well, apart from, as mentioned, data coming from the ground. So I think I'm ready for questions if there are any.
Yes, thank you, Dr. Wang. I think anyone has anything. Let me read the chat. Can I have a quick question on that? I was informed that there is the prototype of the system developing and then already completed the prototype development phase, and then new version of the Aquatic or online questionnaire has produced and now testing. Dr. Wang mentioned you are mentioning the data you provided in the system is from questionnaire, and then you compile all those information into the system. And after this, after your input, there is the process or step to verify your inputs or not.
Okay, so that the phase wherein I collected for that survey was done 2020. So at that time, the platform was Survey Solutions, and it was found not to be as robust as what I think Aquagris now is. So yeah, so it was rather crude back then. We had to resort to just using questionnaires and email them. Not unlike now, as shown by Daniela, you can easily provide the data by going to the Aquagris database or the website. So it's not as difficult as compared to back then. So I think there are a lot of improvements after that.
Okay, you mean for those data in Aquagris meant the data has been already verified. So the policymakers, researchers, those can use it.
It should be, yes. And as mentioned by Graham as well, the assignment is on the national focal persons, but there would be some experts validating the information in Aquagris. So we are assured of the quality of data that will be uploaded.
Okay, just another quick questions to Dr. Graham or the team. After you receive the national focal point or national contact point, I believe that he or she should communicate with the national experts and others. So you mentioned also the nominated experts. That will be based on in-country nominated experts or regional or whatsoever he or she knows. The team of experts.
Yeah, thanks for the question. I think this will vary a little bit, but I think the standard model would be that our point of contact is the national focal point. We would expect that the national focal point will reach out to mostly national experts, but maybe sometimes regional experts to understand the genetic resource for a particular species or a group of species or an aquaculture sector. That expert would then be requested to capture and upload the information, and we would assign an access to Aquagris for that person upon request of the national focal point. We would then not publish that information and allow it accessible through the public data query system until the national focal point has validated the information. So in that case, it may be to do with the level of trust or knowledge that they have with the expert, or maybe they know it themselves. But basically, because we work with governments in the region, we have to have a formal government sign off through the national focal point, who is the dedicated contact point, in order for us then to make that information publicly available.
Thank you for that clarification. I think for the sake of time, I think we should listen from Dr. Graham on the introduction of the online training, as we just touched a little before. Is that okay with you, Dr. Graham, to introduce the online training?
It is, yes. I will try to be as brief as possible. Just check. Are you seeing? Can I just confirm you are seeing the screen?
Yeah, perfect.
Okay, so I would like to talk a little bit about some of the other resources that FAO has available, but I will try to do this briefly because I think it's important to have a discussion at the end, and we lost a little bit of time at the beginning with the audio problem. So we have seen already that we have seen about the global assessment, the State of the World report. Daniela has introduced Aquagris, and we have a prototype already available, but we will soon be launching the new version. And we talked about the GPA. I'll talk about very briefly some other resources that we have available, including an online training to develop a this is more to do with capacity building. So I'll start first with the framework, which is one of the first resources we generated. This is a framework of essential criteria, and it's essentially a framework as in a published document that supports countries to establish the conditions necessary to sustainably manage their AQGR. So it's a kind of document that can be used to identify, it's a needs assessment process that calls for a national dialogue or review to develop an implementation strategy and to review or revise national policies and practices. And this is one of our technical series that is in support of the Code of Conduct for Responsible Fisheries. So essentially, the framework is a document that enables countries to analyze and identify national gaps and needs for sustainable management of AQGR. It enables or supports analysis of 5 different components, looking at information and databases, and obviously Aquagris will fill that need in the future. Look at governance, policy, and planning, capacity building and training for the sector, and the infrastructure and equipment available, such as DNA analysis laboratories, gene banks, etc. And then also at the center of it is the capacity to enable the private sector, because we understand the government can't do everything. And in many cases, genetic improvement ideally should be in the private sector. So then stakeholders can map the current policies, practices, infrastructure, and resources into these elements of the framework. The framework essentially guides that process, and then analyze the requirements and gaps that need to be filled in order to better develop any particular area. So that's a framework. That's one of the first documents that we produced in 2017 or 18, I think. Now I'll talk a little bit about the training course, which is a new initiative, which is actually not yet available, but we expect it to be available before the end of the year. And this is an online training course covering management and development of aquatic genetic resources. It's targeted at a kind of intermediate tertiary education level. It can be used as a standalone training, or it can be incorporated into existing training courses such as vocational education and training in aquaculture, or even for degree level courses. It wouldn't be good enough for a genetics course, but it could be a component of an aquaculture or aquatic biology course. And it's targeted at a range of different stakeholders, but principally hatchery managers, resource managers, and aquaculture students. The course has 18 modules. I'm not going to list them all here, but essentially it's a cooperation between FAO and the Norwegian agency that has a lot of experience in aquaculture genetics called NOFIMA, and they work in several countries in the region, including Vietnam. And basically the NOFIMA aspect of it is the core of genetic improvement, including defining breeding goals, recording phenotypes, mating designs, simple and advanced breeding programs, estimating breeding values, controlling inbreeding, etc., etc. And it goes even through to the role of genetic tools and gene editing. The FAO content is like an introduction and a summary that puts everything in the context of what we have been talking about today. So amongst these modules, each module includes some learning objectives, at least one video lecture that range in length from 25 to 25 minutes. We have a total in the course of around 6.5 hours of lecture material. It includes some interviews, some practical demonstrations, such as how to sample shrimp in a pond, and it lists required reading and further advised reading, and it also has quizzes and feedback. And when it's eventually made available via the FAO e-learning platform, candidates who complete the course will receive an FAO certificate to show that the course is completed. Probably if you're doing it as part-time, it might take 1 to 2 months to complete the course. The course, when it's available, will be made freely available to all FAO members, and so we anticipate it could be taken by hundreds of students across the region and the world. Other resources that we have, just very briefly, we've just recently published 3 case studies on issues of genetic management. That's a case study on major carps in South Asia, genetic improvement of tilapia in Africa, and oyster genetic improvement in Australasia. And we are currently preparing guidelines on genetic management for stocking programs, for example, for stock enhancement, and also guidelines for ex situ in vitro gene banking. We'll shortly be entering a phase where we consult with members, including national focal points, and hopefully they will be published sometime next year. And there's a link there to a full list of FAO related publications. We have many in support of aquatic genetic resource management. But I'd like to bring everything together now from today's talks to describe how these resources can be used by countries to generate specific tools that countries can use. So, for example, the framework can be used to map policies, practices, and infrastructure that's needed to manage effectively your genetic resources. Aquagris, as we've heard, can be used to create a national registry, which is baseline information that can then subsequently be used to monitor and to inform the development of policies and strategies. Training courses such as the online course or even the guideline material can be used to enhance human capacity to manage genetic resources effectively. And then the global plan of action is like a menu of options that countries, once they understand the status of their genetic resources under the 4 priority areas, can identify the key actions that are relevant to their own capacity building and improvement of their genetic resources. So ultimately, these can generate improved capacity. A national register can identify key needs for conservation, the priority farm types that can be targeted for genetic management and improvement. And altogether, collectively, these can be used to develop a national strategy for AQGR management. So just going back to the cycle of work that under the Commission, as you saw previously, we are currently at the phase of country implementation. Realistically, it's hard for countries to do a lot of work at this stage on our first cycle. But what we would like to focus on in this case is for as many countries as possible to use Aquagris to create a national registry. We understand it looks a little bit daunting, but I think once there is a clear understanding of how to classify farm types and wild stocks, it becomes relatively straightforward in our experience. But you have to learn first how to do that. And then maybe some countries can also use that information to start developing a strategic plan for implementation of the Global Plan of Action. And we have also now the tools, we will have the tools to monitor the impact of the work that FAO does and the country responses through the GPA, looking at resource indicator reports every 2 years and process indicator reports every 5 years. So we start the cycle again. So we are about 4 years into the current 10-year cycle. And so we are available to support countries as well as possible over the coming years to start any action that's appropriate in implementing this Global Plan of Action. And I think that's where I can throw the floor back to the chair to discuss maybe what we can do with CIFTEC countries over the coming years. I mean, for example, maybe we can organize a workshop, a regional workshop to train countries in using Aquagris and to actually work with you to start creating national registries for countries that are interested to do that. And yeah, but we obviously we have limited resources. There's only at FAO, there's only Daniela and myself. But we are very committed to supporting countries to enhance genetic management of genetic resources in aquaculture. So I'll leave it there, and I throw back to the chair, and we are very welcome to receive some feedback on what countries might be interested to do.
Yes, thank you very much, Dr. Graham, for your very, very useful information. I think the country also exciting a lot today afternoon in the region, how our people can at least making use of the application of this program to not only policy, but for food security and everything that we are expecting in the near future. Yes, we are now, I think we can entering to the open discussion, recommendations, and way forward. Yes, Dr. Graham just mentioned a while ago the regional workshop opportunity for the region to be supported by FAO program. And I believe that the national registry activities are the key activities that FAO and everyone are looking at inputting from the country. I think we have one question pops up. Does the data provider have to make sure that the data information represents the whole country?
Want to take that, Daniela?
Yeah, please.
Yes, thanks for the question. So, possible, yes, the data should be for a given species, no? For the farm types within the species should be as much as possible representative of the country. But we also understand that, of course, there are different situations for some countries with limited aquaculture production, and where the production is limited to few species and to few farm types, it's much more easy not to do a data collection for Aquagris and to provide a comprehensive snapshot of the situation for the different species produced. But if we take countries like the Philippines, like Thailand, like China, like Japan, where the species farm are many more, and the possible farm types also. So we understand that it can be more challenging. So the recommendation is to start focusing on the priority species and on the most important farm types within the different species. That is where I would start in terms of data collection. And then in any case, so the reporting into Aquagress as every 2 years, no? But within that time frame, national focal points and the experts that in case will work with the national focal points on the data collection will have the possibility to access anytime to Aquagress and to update their information, to enter more information and so on. So, but yes, I will start with the priority resources, probably.
Yeah.
Just
know,
in relation to
yeah.
the specific question about whether it's okay to enter regional information rather than national, I think the starting point for Aquagress is first of all the species entry, and then it's just to consider what is known about the genetic structure of the species in your country. And once you decide how many farm types are, and in some cases those farm types will be regional, but I think in most cases, except for the really large aquaculture producing countries, they probably won't be regional. So I would say that it's not ideal to just consider a region, because you might miss the genetic resources available elsewhere in the country. But if you only have the knowledge for one region, you don't have it somewhere else, then you can do that. But I think the starting point should be to try to start considering everything for farm types at a national level, if possible.
Yes, thank you for that information. I think I recall presentation earlier that you have 21 strategic priorities and 100 recommended actions in the assessment of the report. I think we can have further look on those strategic priorities and the recommended actions. My personal interest in the case study, I think you show us the number of case study. Is there any ongoing case study on genetic tools in stock assessment that you mentioned in one of your slide?
That one is the preparation of a guideline. So this is a guideline that basically, if there is a program for stocking of an aquaculture resource into the wild, the guidelines will basically provide a framework for conducting appropriate risk assessment and decision making to make sure that the risk of compromise to the wild genetic resource is minimized in any kind of stocking program. So it's a guideline for consideration of genetic issues in any stocking program. But I want to go back to your earlier comment about the global plan of action and the 100 actions. Again, that sounds daunting, but the point of the global plan of action is that if you can create a national registry and develop a strategy, you would identify what is the priority, and every country would have a slightly different priority relevant to where they are. So, for example, a country like Norway has already excellent genetic improvement programs for salmon, so it's not a priority for them. Maybe their priority is more to do with conservation. Countries in Africa or Southeast Asia would have different priorities. So I don't want countries to think that they have to take 100 actions because it's daunting. Basically, it's about identifying, it's like a menu of options. And when countries look at the global plan of action, hopefully in the context of having a national registry, they can identify which of those 100 actions, maybe it's only 1 or 2, are the priority to address the most important issues in their country. So we're not expecting countries to look at that and say, I have to do these 100 things. It's a menu of options, and every country would have its own priority.
Yes, thank you for that information. I saw text from Dr. Danila. Yes, I would like to ask the resource person here. I think today we have very good opportunity to listen from resource person from FAO and our colleagues in the region, and I think few further questions and number of people may be interested in developing their own, as you mentioned, the national priority, selecting some of the recommended actions from the assessment report. I'm not sure is that the national focal persons that FAO has in your hand, at your hand, is the one that we are working with. Is that open access on the list of the national focal person, or how
Yes,
safe
I'll
that-
ask, yeah, I'll ask Daniela if she can post the link to the list
Yeah.
of national focal points.
Yeah. I'm going to share the link now.
Yeah, I think in terms of to facilitate the process and developing and managing the work that FAO just presenting, we can, I think countries, they have the national protocol, and those can work together in their countries if they can see yeah, that's very great.
I mean, I don't know. I know that Jude from the Philippines is here. I don't know if we have any other national focal points in attendance who might want to comment, but you know, I would like to have a discussion either now or at some later date to discuss what actions FAO can take and whether we can put some kind of project together to support some CIFTEC countries to take some actions.
Yes, very great. I'm looking forward on that, and I think I would like to request our national representative today, this afternoon, to have a look in the link that provided by FAO. I think in-country coordination is also a very key important issue. Okay, shall I return to the issues that Dr. Graham just mentioned, the possibility of supporting from FAO to the countries in the region in the near future? Yes, Dr. Graham, if you have any message we can have from you.
I mean, I think the message is that we stand ready to support countries. I think we would we have this activity as a TCP with Indonesia, and we hope that will result in a national registry for Indonesia. And obviously, Indonesia is a very important aquaculture country, as are many other CIFTEC members. But that's just one initiative. I believe that a good starting point is to create a national registry, and I think Aquagris is a tool that has been developed over many years in consultation with members, and we believe it's quite a good tool. And it looks a little bit daunting when you start out, but I think once you have a training and once you understand it, it's quite feasible, I think, to create national registries. And then when you have a national registry, it then becomes an important baseline information to make your strategies and plans going forward, and also to monitor your progress. So I think it's kind of a really important first step, and we stand ready to support countries. We would find it easier, I think, to support through regional cooperation with a regional organization. For example, in Africa, we have been discussing quite a long time with SADC, the Southern African Development Cooperation Council. And I think so if we would like to see some members or all members of CIFTEC come together, and then we can coordinate activities to support many countries rather than doing everything on a bilateral basis. So I would like CIFTEC to explore whatever mechanism we can do in engaging with national focal points, but also other specialists in the region, including the participants in this seminar.
Yeah, thank you, Dr. program. I think SafeTech in under this program, I think we have in the future to look at how best SafeTech can put in some of the regional program to support our member countries in providing for example, the national registry and other programs related to the AQGR and Aquatic program of FAO. I think SafeTech will in the future listen to our focal point, our line agency, how if they need further assistance on this matter.
I should
And
say
we have-
also that sorry, just to interrupt, that we are also working with the Philippines now through Wang and also the national focal point, Ms. Joricel Danting, to see if it's possible to build on the work we already did in 2020 to complete a national registry. And I think that would be a very good experience. And then once we've achieved it for one country, we can then have a better idea of the scale, and also the people involved in that exercise in the Philippines can share their experience with other members. So I think it's important to move forward, and we are planning to move forward with the Philippines, but we would like to do it more broadly through regional cooperation as well.
Yes, thank you. And just quick question for our member countries. In case not only for Indonesia, the TCP program, if the country interested in having such kind of program in their respective country, they can contact you or some of you.
Yes, I mean, I think there are regional TCPs as well as national TCPs. I think it's good that we have a national TCP with Indonesia, but I think it would be impossible to generate national TCPs for every country, but possibly a regional one maybe. But funding under TCP program is quite limited, and so any additional source of support elsewhere. And we can also explore our own opportunities, but we are not a funding agency. We are primarily focused on technical support and resource support.
Okay, and we have with us on the floor, Madam Angela, FAO regional office in Asia. Angela, are you there? If any information that you can provide us, how such kind of support from FAO can some country they have interested in joining the program, but they don't have the TCP or whatsoever. If you have any idea.
Yes, thank you, Kunwarwit, and good afternoon, good morning to everyone. So as my colleague Graham mentioned, we do have that way of funding for this specific type of support through the TCP, and we could do either national or explore regional. I'm not sure about the funding right now, but we can look it up. Other than that, we'll have to be a bit more creative on what kind of funding will be possible. I cannot think right now on anything specific, but if they're interested, then we can certainly explore some options, and we can support you on that.
Yes, thank you, Angela. I saw my colleague, SafeTech AQD staff, the current staff, not the expert, Dr. Wang. AQD staff, if you are there, do you have any idea supporting things related to this program? Can I have my colleague from AQD to respond? Because I think you are the most priority one, because you are doing the aquaculture, and those are most relevant issues and activities. Maybe we can start with something aquaculture. Is there anyone there still, or you? Oh, okay. Maybe you are 5 o'clock already. You are not convenient to. Quiet.
Hello.
Okay. Hello. Yes, please.
Yeah,
Madam.
we're still here. Yeah, I'm Marina. So on behalf perhaps of my colleagues at SafeTech AQD, we will take on this with management and how we can also contribute to move forward with this initiatives.
Yes, very promising words from our colleagues from AQD. Thank you.
Yeah, thank you.
Anyone would like to have any questions from the floor? How about Thailand? Thailand, I think you have also, even you are not in the ongoing TCP program with FAO, but you have, I think, produced a lot of aquaculture products from the region to the world market. Any updates from Thailand, if you have? None. Okay. How about my colleagues in Secretariat and other SafeTech departments, MFRD, MD, IFRD, MD, and MFRD, if you have. Okay, I think I can conclude in this way. I think we will work with FAO headquarters and our FAO in the region in order to have a better coordination, collaboration among people who are involving in this program with the countries and other regional organizations as well. And I think we have really limited number of people in this genetic field, but we do our best to explore future opportunity with arrangement, supporting technically to find the best supporting from our organization to you. And last but not least, I would like to, if none, we have Deputy Secretary General of SafeTech, Madam Tomoko Nagasato, to give some speech before we say goodbye to everyone. Madam, please.
Thank you, Vito-san. Yeah, ladies and gentlemen, hello again. Can you hear me? We have now come to the end of the webinar. On behalf of SafeTech, I would like to express our sincere appreciation and gratitude to the resource person from FAO, Dr. Graham, and Dr. Daniela, and also from Philippines, and our former colleague, Dr. Maria Lona, for sharing with us the important information and your experiences of aquatic genetic resources of their crucial role in sustaining global fisheries and aquaculture production. I believe that our participants have gained knowledge and understanding of subject and get a foot on the door for future contribution and actions in this field. I also would like to thank all participant member countries for your sincere engagement and insightful contribution. Thank you. Finally, I wish you all continue in your endeavors to conserve, sustainably use, and develop aquatic genetic resources, Southeast Asian regions, and declare the premium growth. Thank you once again, and have a good day. And Italy is now enjoy a good lunch, and yeah, our member countries and good dinner. Thank you.